My name is Aneri Pradhan of Klimatic Group, and today I'm with
Mohsen Tabrizi. Hi, my name is Mohsen Tabrizi, and I'm from BESS EPC.
Great, nice to meet you.
Nice to meet you too.
So, yesterday you actually gave a really good presentation on
you.
the BESS Academy. And so, kicking off with that, what can learners learn from the BESS Academy that they wouldn't be able to learn in like a typical engineering studies program?
So basically, there are not a lot of knowledge around BESS. So in the BESS Academy, the first question actually why we made this BESS Academy is that because we saw there are like many people struggling from knowledge on this. So either from engineers, investors, and so on, and also the clients that they are really try to learn something about that, but they don't see anything be like in the same place and talking only about the BESS. So we make this BESS Academy to answer all these questions, to say how how is electricity generated? Very quick, in 5 minutes. Then we continue by why BESS, we need BESS, why we need saving energy storage for later. And also why you say like what, because of these challenges, like the challenges that the solar generation and the wind generation brought to the table, which is like lack of inertia. So we are talking about that, and then we say why is there, that is there, and why because of that we need BESS. It's not something, let's say, something good to have. It's something must to have. So otherwise, something just like what happened last year, April in Spain, could also happen here because of lack of inertia and the whole system went offline because basically they didn't have any BESS installed. Yeah, and then it took them 18 hours to get the whole systems again online.
Wow.
But the whole problem happened in 5 seconds. So in 5 seconds, they lost electricity. If they had BESS and PCS obviously connected, so they could be just in 20 milliseconds, the whole thing would be stabilized. But now what happened? Just imagine the lost stuff.
Yeah, it sounds like we need lots and lots of skilled people in this sector. And what technical mistakes do you see often repeated during project design and deployments that better skills could address?
So basically, BESS manufacturers, they are not focused on one market. They are working on different markets. So I say even the smallest BESS manufacturer, they are exporting to 20, 30 markets. So the biggest one, they are maybe exporting to 150 markets. So any different market, they have different specifications, of course. And of course, I'm trusted with almost any manufacturer. They can see these specifications. But the point is, a lot of them, they don't see how hard it is to get the grid permissions. So I see people, they really underestimate this one. They design, they send the project, the products and everything, and then you see everything is at the side, but it's stuck. Because at the first of the day, at the beginning, they didn't got the grid permission, for example, or the building permission, which is also dependent to the grid permission. Yeah. So this is one of the very critical points. And you just imagine you design the system of 250 megawatt power, but the grid doesn't give you that much power. So to connect there, so the permission is going to be 50 or 150 or so on. So it's a huge mess. Half of the products you have to send it back because you're not allowed to connect it there. Or even you brought the thing, but the thing is like they need to be reset and reinstalled and so on. So you need a lot of technical changes to the products, and you have to do that on the site. It happened before. I remember that it was a Slovakia project. It was 0, maybe 5 degrees or so. I went there with one colleague of mine, and then we had this on Saturday. I think it was the time that the network operator, it was the second or the third appointment of the network operator. So we went there, we changed every PCS's main boards to be able to make the changes. And you just imagine several thousand screws only for 4 PCS boards. So basically 4 PCS, each 3 boards, 12 boards. But it was several thousand screws we have to take out, and then we have to reinstall back, and then do that whole thing. So they could avoid it if they have it planned in advance. So grid permission I say the first problem is always grid permission. The second is also grid permission, and the third is also grid permission. Yeah.
Wow, amazing. And so for students now who
Yeah.
are looking to enter and become BESS professionals, what skills or capabilities would help prepare them for the next 5 years?
Okay, so I think now we need commissioning managers, and we need O&M engineers, which they just have to support the BESS during its lifetime, which we are going to get a lot of them in Germany, and they need to be continuously and maintained. So boards need to be changed, need to be maintained, need to be checked everything if like the BESS is working properly, and prevent any mistakes. So they have also preventive maintenance. So I think O&M engineers, commissioning engineers, we need like lots of these guys.
Okay. And so now switching to the topic you just presented on, which was really fascinating. What stage of the development process creates the biggest bottlenecks today?
Okay, so first is grid permissioning.
Yeah,
yeah, that's
related.
really hard. Yeah, so we faced like the first projects that we had, like almost a year and a half to a year 9 months. We faced the problem of grid permissioning, and now because of that experience, we make projects 8 to 10 months. Like I'm talking about big projects, like the utility scale projects of 2 gigawatt hour, let's say, capacity. So we make those at like 8 to 10 months, get the grid permission. And after that, the most critical thing is commissioning. So at the commissioning stage, we need to combine everything, integrate everything from the batteries, from the PCS, from the switchgear, and from the transformer. Everything we have to integrate and put it on the to deliver the project to the grid and connect it officially to the grid operator, and changing any different scenarios. What happens in blackouts? What happens if the frequency goes high or goes low? And all of these things, which is really critical as well. So at the beginning, grid permission is critical, and also the commissioning part at the end.
Yeah, great. And what separates projects that reach RTB efficiently from those that get stuck?
Well, first of all, we have here in Germany at least, they're saying between 90 to 95% of the projects that fail.
Wow.
Big ones. So the utility scale ones. So there is no doubt on at least 90%. Okay. So you imagine you go through everything, and if you're talking about like 2 years ago, even grid operators, they didn't know that much. Like, what do they need? Do they have to ask from the power plant to provide them? They didn't have any BESS in the system, right?
Right.
So, but now it's totally different. They know what they want to do, but there are too many applications at the same time. So from last year, what changed is like first come, first serve. It was from last year, but now they give a chance to anybody to present their let's say the project, to see like how developed is their project. If it's developed, it's if they see it really good, so they follow them. So they push it forward and put it on the line. So just to go and let's say do that project in advance, because those guys are more prepared. And I suggest that any project owner and project developer to be prepared, have everything prepared, and also try to ask other companies to consult them, companies who has already done this. Because grid operators, they have actually they receive too many inquiries, too many, and they have actually no time. They can't spend that much time on you and to tell you and teach you what you need. Either you're ready or you're not ready. Go get consulting, go get help outside. So be prepared.
Wow. Okay, that's great insights. And you talked about 5 years ago. Let's zoom 5 years ahead. Where do you see development processes changing as the market begins maturing?
Okay, so 5 years from now, I believe the equipment price will be really low, and also the permissions granted, lots of permission already granted in 5 years, right? So you will see lots of projects coming online. but there is no way that we can achieve 700 gigawatts in Germany. That's no way. So they always put the goal, which is a need in Germany, but there is no way that we can reach that. So that means the market has huge capacity. So many companies has to come into the market to build this power plants. So because the peak shaving we have it's huge. The excess energy we have it's huge. The curtail we are making is huge. So in 5 years, not only 5 years, in 15 years, even this market is top. Because it also continues to change and we have to be replaced. Like the batteries in the next 10 years, they have to be replaced. And also the new technology is coming, right? So yeah, I see some people actually saying, we don't want to go with now, we have to wait to see the next technology. But the fact is, technology is growing. If you want to wait next 4 years for the new, let's say 3-4 years for the new battery, it's like go to the next level, like not the lithium-ion batteries. Even at that time, you will see another technology coming. So you can't say, I wait for the next technology. Then you have to be always waiters.
Right, yeah. Right. Well, thank you so much, Mohsen. That was some really amazing insights. I hope you have a great time in
Thank you. You too. Thank you very much. Thank you.